Welcome everybody. My name is Danny, and today we're going to talk about some Mastercam multi-axis capabilities. We can Mastercam does provide simultaneous 4 and 5 axis programming capabilities, and it can improve your productivity and your part quality as well. Unlike anything else, it's important to know when to use it and how to maximize your efficiency. When you're programming on a daily basis. So we need to see if we can, take control over the cut pattern, the tool axis, collision avoidance, stuff like that, to maintain perfect cuts, all the time. So today we're going to look at a couple of things. We're going to look at curve drill 5-ax, when to use it, when not to use it. And then we're going to show you a multi-axis kit, and we're going to see the differences and what they can do for you. And then we're going to talk about, 3D tool paths. And again, curve drill 5-ax is for following, a path. And then we got some surfacing tool paths. And then how can you improve those if you maybe decide to choose a multi-axis tool path instead, and you can probably get better results and even, faster cycle times. And then I'm going to show you some Mastercam add-ons, Blade Expert and Port Expert. And these two are very specific. They have very specific functionality, and they automate machining some very complex shapes. So let's go ahead and let's get started. All right. So the first thing I have is this part up here, and I'm going to show you the first thing we're going to cover is curve drill 5-ax here, like curve drill, say versus contour. If you're familiar with Mastercam, we could do contour and do an axis substitution, say for this shape right here. See the shape, everything kind of points toward the center, and it would not be hard for a tool to just, we can take the tool and tell it to wrap it around this geometry. But then what happens when you have this shape right here? This shape, it does start off where the tools are pointing, the walls are pointing toward the center. I'm sorry, I said tools earlier, I meant the walls. But then it changes direction, and the walls then become parallel to each other, and they're not pointing toward the center. So simple axis substitution will not work here. So let me show you a few examples how one works for axis substitution for this side, and then we'll do a curve drill 5-ax. So let me start off with contour. And I've got some wireframe up here just for clarity for today. We could use the solid if we wanted to, but I wanted to make the selections pretty bold and very easy for us to see. So I'm going to go ahead and just select this geometry right here. It is wrapped. It's wrapped around this ID diameter. I'm going to go ahead and select OK. And I do have a tool ready to go. So I have a 1/2-inch flat end mill here. My cut parameters. Now, it is going to default to 3D, and I'm going to switch this to 2D, and I'll explain why I'm doing this here in a minute. And I'm going to go ahead and set my linking parameters the same way. I'm going to set my linking parameters as if I was cutting a part in 2D. I'm just going to leave everything in absolute, and I'm just going to cut everything to 0 here. Okay, that's the depth of my cut. Now, changing my contour type to 2D, and then setting my rapids and my feed planes to only 1 inch. This part is obviously bigger in diameter. We would think this is gonna, crash into the part, but it's not. We're gonna go ahead and do axis, rotary axis control here, and we're gonna do axis substitution. We're gonna substitute about the Y, and I'm gonna right click right here and say about the diameter of this ID right here. See if I can pick it. There you go. And then I'm gonna unroll it. Because the geometry is in 3D, internally, we're gonna unroll this geometry, treat it as 2D, make the toolpath calculation, and then wrap everything back up and give you the rotary toolpath that you're looking for. Go ahead and select OK here. So now when I backplot this, here's my tool. It comes in. It's going to go around the part. And that looks pretty good right there. All right? Fantastic. Yeah, the toolpath a little short this time. Little setting I forgot. But we get the idea of rolling the part around there. Now, let's go to the other side here. Okay? Let's look at this side. And I'm probably going to isolate the geometry here to make it easier. So I'm going to go ahead and select all wireframe. And I'm going to hide my model. And I'm going to focus just on this top part. Now what I'm going to do is I'm going to do a curve drill 5-ax. So going back to my tool paths, Going into my multi-axis panel here, I'm going to go select curve, which is our curve drill 5X, and I'm going to grab the same tool, and then I'm going to go to cut pattern here. I'm not going to really worry about the holder or the stock today. We're just looking at the motion of the tool path. I don't really have any stock defined. I'm just going to use the curves. We're just going to do one simple path. We're not really looking at removing, a large amount of stock today. So on the cut pattern, I'm going to go ahead and use the curve type through the 3D curves. We have a few selections like, surface edge or all the edges or surface single edge. But again, for clarity, I'm going to use the wireframe. And what I want to do is I want to select that bottom profile. I'm going to go ahead and say select the curves. And instead of me stopping at each of the branch points, I'm going to go ahead and turn my filter on. And I want to make sure that I select only green. I'll select OK to this. My filter settings are set. I have a little indicator here saying that I have a filter on. And then I'm going to chain the bottom profile. It ignores every other color except for the color that I have actively selected. We'll select OK to this. And then we're going to, again, computer comp is a 1/2 inch inch, so we're going to, do a radial offset of 1/4 inch. My 2-axis control, I'm going to select the lines here. And I'm going to go ahead and start picking my lines, right? And I'm going to pick these lines, and I'm going to make sure that the vectors are pointing away from the curve that I selected. Now I have a few of them here, and there's nothing wrong with that. You get more toolpath control the more you select. And I'm just going to walk them around, and it doesn't take that long. Back to the side. They don't have to be touching. I did select that one edge where that chamfer was at. They can be separated like that. We'll select OK to this. And we're going to rotate about the X. This all looks good. And then our linking parameters, the same thing. I'm going to say 1 inch above the part, just like I did in the contour example. There is no rotary axis to do here because this is going to be a rotary toolpath already. We'll select OK to this. And I'll go ahead and backplot this. And there's my tool here. Now he does rotate a little different there. Maybe it's a little better if we put the model back on, like so. And maybe if I go ahead and backplot him and turn my rotary axis on, he's upside down because he's coming from the other side. Let's do rotary axis substitution. Backplot it this time. Let me spin him around so we can see him. Everything is getting away from me today. Right, let me try that one more time so we can see it. So there, see, it's not rotating there because the walls are parallel. Then he comes back up. We do it one more time, slowing him down for the exercise. And he's going to come in. It has rotated. We've gotten to a certain angle. It's not rotating. It's just cutting in that view, in that position. And then when he comes around this corner, he's going to rotate around and then come out of the part. All right. So that is a really simple and good example of when to use contour, which would be a good example on this side here, and then when to use curve drill 5X when you need more control because the walls that you're trying to cut, are changing. We could do swarf as well. We do have options for swarf milling. We have, an old style swarf and a new style swarf. But for today's exercise, we just want to talk when would be the difference and when would you decide to use something like, say, contour or curve drill 5X. Okay, so moving on. Let's go ahead, and I believe the next thing we're going to talk about is the 2-axis kit. We'll go ahead and open up another file here. Let's go to the multi-axis kit sample that I have prepared. I'm not going to save this. So we have a file here, and we have quite a bit. We have some features, and we have some add-on tools for Mastercam that really help automate what the visualization that it provides. I guess that's the best thing for me, and I'll show you here in a minute. So if I go to Design Tools, we have a Mode Plus add-on here. And if I just do a curve 5x, because we are talking about, all the curve style toolpaths, we're going to get a little window that shows up, and I can decide what type of toolpath I want. I can, same thing like the other way. I can do edge paths. I can go ahead and do curve paths. I can also do swarf. I'm actually going to select swarf in this example because this is a curve type of toolpath here. I'm going to select this wall. I don't have to go. The automation of this is, if in the previous example I had already laid out all that wireframe, and I didn't want to sit there and just draw that wireframe in front of y'all because it takes a few minutes, and then you have to go select all that wireframe. Here, it's already automated for you. It's very intuitive. You just pick this wall and say, oh, I want to go ahead and do a toolpath right here. I'll go ahead and accept this, and now it shows me the toolpath and even shows me all the vector lines. Right? Select OK to that. Okay, there you go. Sorry, that wrong button. And I can sit here and I can simulate this toolpath. If I just highlight it, hit simulation, we get some of these windows out of the way so we can see it, and it runs, right? So there's my toolpath. It's going around the part, and I think we're going the right way, but see how it's tilting too much, especially in these areas right here. And it's also violating the part, we can just tell. And it's taking the default tool. We'll go ahead and close this down. I can go edit this tool right here, and we'll go ahead and say from a Mastercam, edit the tool. Let's go to Mastercam, and we're going to go select the tool here, and I believe I have a 1/2" bow end mill. But we're going to go ahead and do that. I'm going to do a side offset, give them a little bit of room. We'll select OK to this, and let's go ahead and simulate it. Run this. I think I'm on the wrong side, right? Let's go back to this guy, edit this guy right here. We're going to be to the right, or actually, you know what? I knew there was something wrong. Let's go here. Let's go up here and we'll say reverse this toolpath. Now let's simulate it. Now he's on the right side. I thought I was doing something wrong here. All right. So again, I'm just looking at the toolpath, and right here we're just tilting way too much, and I want to clean this up right here. So let's go ahead and fix this. We have all kinds of tools right here, right on the fly, and the one I'm going to choose today is just to add and remove some of these vector lines. Okay. Again, like in the previous example, there are lines. The system here already automatically calculated them or added them for us. I'm going to get rid of some of these ones that are leaning too far, like this. And as I'm picking them, it starts to pick the shift the vectors for us, and it starts to clean them up. I might just get rid of all of these here between the two entry positions. I want to keep this one and this one. See, that's a nice clean looking toolpath. That actually shows you the motion of the tool. Let's go over here to this side and we'll do the same thing. We'll just go ahead and clean these up right here. And again, it found this motion from the model, and we're just going to override that motion right there. So go ahead and select OK to that. That looks good. And then if we go ahead and run the simulation again, let me spin this part around and we run it. Oh, let's do it again. And we get some nice clean toolpath right there. And we can do some other adjustments. You can just go in here and you can add vectors, you can subtract them, you can modify them, you can tilt them if you want to. We have all kinds of tools right here. But again, just a quick, simple example of what we can do here. Select OK. I'm going to take this toolpath and I'm going to add it to a group. And once he's added to a group, we can take this guy. Oops, we can generate a toolpath. And then we go ahead and close the window down. And the toolpath is here in your Mastercam operations manual, operations manager, sorry about that. And it's ready to go. We can modify it, add curve, lead in, lead outs, and stuff like that. But again, just trying to show you some of the tools that we have available. That was a real good, clean example of how to use the multi-axis toolkit that's available, here from Mastercam. Alrighty. The next file I want to show you, I believe it's a. Let's go. I got them here on my desktop. Let's see when to use 3D and when to use just 3-axis. Let me go ahead and open the file. I'm not going to save this. Again, a very simple example. I just want to just show you some simple toolpaths here. I already have the machine already called up and everything. I'm gonna go to toolpaths, and something like this, you know, you could some simple contours. You cut around this. You cut this step. Go ahead and you want to cut this shape out right here. And I'm not going to rough it out again. I mean, just again, a real quick example. Let's use flowline toolpath. Everybody likes to use flowline, so I figured I'll just show flowline here. Under the 3D panel, I'm going to go ahead and select flowline, and I'm going to cut that surface. I'm going to end my selection. I'm going to show my flow direction. I'm going to change it so it goes back and forth along the X. I will select OK to this, and I'm going to select a 1/2" ball nose end mill. And I'm really not going to make a lot of selections here. I'm just going to select OK. In order to get a good, nice, clean surface, I'm going to use a 2000 scallop height. Select OK. And then when I backplot that, we're going to get our tool that just goes back and forth along the part. Nothing wrong with this toolpath. Absolutely nothing. It works just fine. Okay. But if you have a 5-axis machine, and let's say you want to work on cycle time, you've done good time cutting around the part with the contours. Well, you can use the same tool. Let's go ahead and go over to the multi-axis panel, and we're going to use flowline. Where is he hidden on me? There he is, right there. Flowline, and I'm going to pick a bull nose end mill this time, and I'm going to go ahead and select my cut pattern. Same surface. I'll select OK to this, and I'm going to do the same direction like I did in the previous operation. I'll select OK to this. Same thing, zigzag toolpath. The difference being here, I'm going to go ahead and do the pattern surface, which is the same one. The difference here is that I can change my step over here. So my step over, I'm using a 1/2" end mill. Let's say I do about 400,000 step over, because I can keep the bottom part of the tool perpendicular to the surface. We'll just go ahead and linking parameters, go ahead and drop them down as well for this example. And we'll select OK to this. And now when I backplot, I'm going to still get the same surface finish, but it will take me less time because I'm able to do larger step overs. But that's a really good example of 3D versus multi-axis. Both cut the part. They'll make the part just fine. If you have the machine capability, if you have a 5-axis machine and you want to improve on your cycle time, this would be a really good way of doing it. All right. So we've covered curve drill 5-axis. We've covered the kit. Showed you a quick example of when you could use 3D or when you can use multi-axis. And let's go ahead and move on to, let's go to Blade Expert. So I'm going to, again, go to my desktop, and I have a Blade Expert example right here. And I'm not going to save this. Okay. So now things are going to start to get a little more complicated. I already have a stock model of where we're going to start at. You do have to create a stock model, especially if we're going to rough this out, and that's the example I want to show you. I'm going to turn that off, and I believe I have a tool ready. I have that same 5/8 end mill that I've been using all day. It hasn't worn out. All right, so now we're going to go back up here into the multi-axis panel again, and let's go over here and select the Blade Expert. And again, this is a can you cut this part with using regular axis, multi-axis toolpath. If you have the multi-axis add-on, you can use a unified toolpath. You can do a flow line. There's all kinds of toolpaths that you can cut this, but all of them are going to require that you create some extra geometry, create some splines to help guide your tool, especially when it comes to tilting and so forth. And what Blade Expert and Port Expert do, they bring this very high level of automation here, and I'll show you. I'm not going to worry about my holder. Well, I already have it defined here. The stock, I'm going to go ahead and select my stock here. I called it R1. And then all I simply have to do is come up here and pick a pattern. So I'm going to do some roughing. It's going to be offset from the hub. I'm going to do zigzagging from leading edge. I'm going to start from the center and work my way out both directions. And then my step overs here, my maximum step over as far as sideways. Let's say I'll go 125. And then I'm going to go ahead and do 125 for my depth cuts as well. Now all I have to do is just go define what I want to cut. So here, the blades and the splitters, if I had splitters, those would be the half little blades in between there that you'll see sometimes. And we're going to go ahead and select this. And that's one side of the blade, and that's the other. I'm probably going to add, that should be good right there. I'm going to select OK to that. And stock to leave, I'm going to make sure I leave myself plenty of stock here. And then the fillets, I'm going to go ahead and pick the fillets to cut. I do want my tool to kind of come around the corner a little bit, so I'm going to pick those two fillets right there as well. I'm going to end my selection, and then it's asking for the hub. We're going to leave some material in the hub, and I don't have to sit there and create extra geometry. I'm actually using the model. Okay, just taking the information that the model gives me. Let's get this out of the way. I'm going to end my selection. I'm going to go ahead. I will bump up the tolerance for this example. I can tell it, the number of segments I want to cut. I believe in this example there is 1, 2, 3, 4, 5, 6, 7. We're just going to do 1 for now. All right, and let's continue on here. So the tool axis control, I'm really just going to take all the defaults here for right now. My linking parameters, it is on automated, and it kind of creates some loops that I don't want to do for today's example. I'm going to go to just feed distance on both of them, kind of clean things up a little bit. Taking the default stuff, everything seems to be okay. I'm not really going to no other selections other than make sure that everything is in the top plane here. Just going through and making sure everything's okay. Go back one more time. Got a roughing. The part definition looks good. We'll just go ahead and select OK to this and give it a few minutes, and then it'll calculate a toolpath. There's my roughing toolpath right there. Let's see how this looks like in simulation. I'm going to go ahead and I believe I have my stock model selected correctly here. I do. Let's go ahead and go to simulation. Open this window up, kind of get all this stuff out of the way. There's my tool. See if I can slow him down a bit. Run him. And he's going to go ahead and just cut that out. And that's a nice clean looking toolpath right there. All right. We can do a quick stock compare, see how we're doing. It did not violate anything. That looks pretty good right there. Oops. Zoom in. Plenty of material. Close them down. Now, if I wanted to down rough the rest of the veins here, so I got 1, 2, 3, 4, 5, 6, 7. Just wanted to make sure when I counted them just a second ago, the part was an isometric, and I thought I missed one. So we do have 7 segments. We are going to cut all of them, and we're going to start at segment number 1. And I can select OK to this. And just like that, we're going to have all the cuts for all the veins. I can go back to my simulation and run it. It's going to cut one vein at a time. So now there's times when you're doing something like this, and the guys that have cut impellers, this may cause an issue when like you're running across this thin wall. In this example, obviously, it's very simplified, and you may not want to cut everything to full depth and then move on to the next one. So let's go ahead and pause this here. We do have selections to saying, oh, let's go ahead and do it by depth of cut, say for example. And then I'll select OK to this. It'll sit there and recalculate the toolpaths, and let's go ahead and see the result. Go ahead and run this again. So now So now it's taking it by depth, and you kind of want to do that to help keep the part rigid as much as possible. So you kind of just working your way down vein by vein, and then just you still have all this material here, and that looks like it's working pretty good right there. Wanted to finish up and do a quick stock compare and see how good I did. Did I crash or not crash into the top part? We'll check here in a second. And we could have done some larger step overs or even used a larger tool. And the system will tell you, like, if you want to use a bigger tool and it cannot reach in here, it'll prompt you and say it was not able to remove all the material. You can do another stock model. Then you can go ahead and pick that stock and tell it with a smaller tool that you want to machine that area. We have all the same kind of tools that you have, like when you're doing 3D surface toolpath, and it says, hey, you want to go do remachining. We have the same tools here. Let's go ahead and do a stock compare. And that looks really nice. I like the way that works. Sometimes I surprise myself. All right, we're going to go ahead and close this down. Here, looking at my list over here, my cheat sheet. Port expert. Let's wrap this up and let's go do an example for port expert. So with port expert, again, it's just like the blade expert. It's all about levels of automation. So let's go ahead and give it a try here. I'm going to go ahead and do a port expert. I already have a stock model defined. I didn't create a tool, so let's just go ahead and create a tool. I'm going to create a lollipop tool here. I'm going to select next. Let's give it a dimension, probably about 1/4 inch in diameter, and that'll make the shank here a little smaller. I'll make them like 3/16. And the cutting depth, I'm just going to go and leave them at 1/4 inch. That should do it right there. I'm going to select OK to this. Holder, we probably should get an extended holder here. Let me pick another library. What did I do wrong here? Open a library. I want to just open up a library here. Don't know why it was asking me if I wanted to save the file. And probably somewhere around here, we pretty should have some nice, good extended tool holders, taper tool holders that are pretty common to use when you're doing blade expert like this. How about we use that one right there? And I'm going to bring the projection down to the tool. And then for the stock, let's go to a roughing toolpath here. We're going to rough it out first. And we're going to go ahead and use the stock model that we have predefined already. And then do a roughing. I'm going to leave plenty of material on the outside here. And then we're going to, instead of going from both directions, we're just going to say from the top. And we're going to try to take this tool as far as it can down from the top. I'm going to let the system calculate how far down that tool can go down that shape right there, which we're fixing to define. I'm going to open up the tolerance here. And then, the machining geometry is right here. I'm going to go ahead and just pick, again, what defines that shape right there. I'm going to pick everything that's inside that area right there. That looks pretty good. Kind of like that. Keep it pretty simple. Again, we don't have to go create extra geometry. If I say in my selection here, it's going to automatically create the spline. If you were doing this with, say, like a unified toolpath, you would have to create your upper and lower guide curves. Then you would have to draw a spline that defines the middle of that shape. And then you would have to make those selections to get your toolpath control, doing it that way. Just as an example, I don't have to do any of that. This is a really nice tool, a really nice toolpath here. Collision control, everything else looks okay. I'm just make sure that I'm in the top plane. I'll select OK this. My stock definition. I do not want to close this. I thought I selected that. I forgot to hit that button right there. We'll select OK to this. Give it a second here, and then let it calculate a toolpath. There we go. Nice little toolpath there. I think it went pretty far. That's pretty good. I'm kind of unrendering it. We'll go up here and run the back plot. Tool comes down and it's going to start to, ooh, I got this going pretty fast. Slow them down a bit. And the tool is just cutting there. Let's go to the verify on this one. And I think I have my stock correct. I have been working with this file here. So we'll go ahead and cut this. This seems to look just fine. I can't believe that tool made it all the way down, almost all the way through there. We can't control that and say, we wanted to not go that far. Just being conservative. We'll just go to the midpoint. Recalculate that. And we'll go ahead and backplot that here in a second. There we go. And if I unrender that, that only went so far down. And then we can go verify that again, or run it through verify. There's our tool right there. That looks pretty good. Run the stock compare here, make sure we're not hitting anything. And again, made sure I left plenty of material there. All right. I don't think my stock model is matching up my actual model here right now. I knew I was messing around with them earlier. Okay, and then the last thing I'm going to do is I'm going to rotate this. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to go ahead and use transform toolpath, kind of show you that you can. We do have, just like the other one, there was a point I was making to this as far as like if you wanted to put your utilities here, and if you want to transform these in a number of times, this is still good here. But then I've also been asked, can you still incorporate regular old toolpaths with this? So, yeah, I forgot the number. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I do a regular transform toolpath, right, we're going to rotate this. I'm going to rotate the NCI. I will copy the source operation. Let's say 10 more times. And we'll go 360 divided by 11. Right? If for some reason you want to do it this way, you most absolutely can. We'll do this around the top. And then we have the rest of the toolpaths here. Okay. The things that we can do when it's transforming is then we then can control if we needed to have if a lot of times we're doing these type of toolpaths, the multi-axis toolpaths, then this is the reason why I brought up using the transform. You may need to add an extra toolpath before and after, say, a point position of where it goes to and where it comes out. You need more of that control. And if you need that additional information, and if you just do the internal transform here, you're not going to get that. So doing an external transform like I just did now gives you that option. We'll go ahead and select all, verify this, and we'll go ahead and run it. I knew there was a reason why I did the transform. My mind went blank there for a second, but there is a reason for it. All right, so we're going around, just doing some rough tool paths. That looks pretty good, like so. And then we'll let this finish. And then we'll do another stock compare real quickly. Everything is looking pretty good there. And then we can just take, actually I'm just going to take this tool path. I'm going to copy it, or I'm going to be bold here. I'm just going to copy it afterwards. And if we wanted to change the strategy to, say, a finish around, I'm going to still leave material just in case we need to come back with a smaller tool. Let's say I leave 50 thousandths here. Just have it take material off. I'm not going to change anything else. Just select OK to this. And let it calculate that tool path. Let me turn those tool paths off. And then we backplot just this one. Oops. Sorry. That one was ghosted up because I did the copy here. Backplot them. And now he's doing a little finish toolpath. I should probably lower that down a bit. My step over should probably be a little less. But we do 10 for the exercise and select OK. And then we'll backplot that. That looks starting to look pretty good right there. I like it. Doing some ramping in up there. So let's go ahead and I'm going to transform this toolpath. I'm just going to say copy the transform over, and then just pick the previous operation again. And if I pick both transforms, and I'll run to verify one more time, and let's see how this looks like. All right, let this run. Got some nice good step overs here, and I purposely did not pick the top fillets and so forth for the exercise today. It's just a matter of speed. I know we only have a certain amount of time, and I'm trying to cover everything that I can here. So now it's going to go ahead and finish the ports. That looks pretty nice. It found out where the rest of the model was at. I think we're partly tapping that higher stock because I noticed that stock was a little higher, longer than what I had there. So it might look a little odd, but for the most part, that looks pretty clean right there. Again, just real quickly, just it didn't take me a lot of geometry selection. I definitely didn't have to create any geometry. Not saying you don't have to. There might, depends on the model. You might get a model that's, you know, that can be challenging, and we've all run into that, and we still have to create some extra geometry. But when it comes to the actual toolpath, it should be okay. I think I may have bumped into this, but stock is not exactly correct there. But for the most part, yep, that's what I thought. My stock's kind of high, but the toolpath itself looks nice and clean right there. All right, guys, that's all I have for today, and I hope you enjoyed the presentation.